The star Betelgeuse, a red supergiant monster found in the glorious collection of Orion, has long charmed stargazers and cosmologists alike due to its sheer size and brilliance. If Betelgeuse were placed where our Sun is, it would touch the orbit of Jupiter, declaring its tremendous size. Despite being approximately 642 light-years from Earth, its enormous size makes it one of the brightest stars visible to the naked eye. However, Betelgeuse has exhibited odd behavior, such as surprising dimming and brightening cycles, which many experts believe signal that the star is approaching the end of its life. The famous physicist Brian Cox recently stated that Betelgeuse is on the verge of a spectacular explosion, expected to occur within the next 14 days. This event, known as a supernova, will mark the end of Betelgeuse's life but will offer an exceptional opportunity for scientists to study one of the most fascinating and powerful phenomena in the universe. As a red supergiant, Betelgeuse is classified as one of the largest and most massive types of stars. It has been on the astronomical radar for decades, but its recent unusual fluctuations in brightness have sparked theories that it is preparing for a massive explosion. When a star like Betelgeuse reaches the end of its life, its core collapses under its own gravity, leading to a colossal explosion that releases an epic amount of energy, radiation, and cosmic material into space. Betelgeuse's impending explosion is expected to be a Type II supernova, a specific type of stellar explosion that occurs when the core of a massive star collapses. This core collapse triggers the release of neutrinos and radiation, creating a shockwave that destroys the star. The explosion will be so bright that it may be visible from Earth without telescopes, potentially even outshining the moon in the night sky for weeks or months. While such an event would not normally be catastrophic, Betelgeuse's distance of around 642 light-years ensures that, although the explosion will be visible and dramatic, it will pose no threat to life on Earth. Nonetheless, the event promises to reshape our understanding of supernovae and other cosmic phenomena. A supernova is potentially one of the most powerful events in the universe, releasing more energy in a few seconds than the Sun will emit over its entire lifetime. Betelgeuse's explosion will not only be a breathtaking display but also a groundbreaking moment for science. Experts are eager to observe this stunning event from its earliest moments using a variety of ground-based and space-based telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, JWST, to gather as much data as possible. When Betelgeuse explodes, it will emit a vast spectrum of radiation, from visible light to gamma rays. One of the most crucial aspects of the supernova will be the flood of neutrinos, elusive subatomic particles that rarely interact with matter. Neutrinos from a supernova can actually reach Earth before the light from the explosion due to their ability to pass through almost everything without being affected. Observatories like Japan's Superkamiokande and the Ice Cube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, providing an early advantage in observing Betelgeuse's final moments. The explosion will also provide essential insights into the creation of heavy elements. When stars explode, they produce and disperse elements such as iron, gold, silver, and uranium, materials essential for life as we know it. Studying Betelgeuse's supernova will offer scientists a clearer understanding of this process, which is vital for understanding the formation of planets and the chemistry of the universe. While Betelgeuse's supernova is not expected to have harmful effects on Earth, it will interact with our planet's atmosphere and magnetic field in fascinating ways. The energy burst from the explosion, particularly the release of cosmic rays and charged particles, could result in more intense auroras, extending the regions where the northern and southern lights are visible. While these cosmic rays could impact satellite communications and some technologies on Earth, the disruptions are expected to be minor and temporary. Perhaps one of the most exciting aspects of Betelgeuse's explosion is that it will be visible to everyone on Earth, not just professional astronomers with advanced equipment. For weeks or even months, Betelgeuse is expected to be the brightest object in the night sky, potentially even visible during the daytime. This spectacle will captivate not only scientists but also amateur astronomers and the general public, sparking renewed interest in astronomy and the universe. Scientists have long speculated about Betelgeuse's demise, but Brian Cox's recent statement adds urgency. Observatories worldwide are preparing to monitor every phase of the supernova, and the data collected will be critical, potentially transforming our understanding of stellar evolution, supernovae, and the distribution of heavy matter in the universe. Betelgeuse's supernova will allow researchers to refine their models of massive star behavior. Being relatively close to Earth, it offers a unique opportunity to measure how energy from such an event travels through space. By observing the light and radiation from the explosion as it interacts with the interstellar medium, gas and dust between stars, astronomers will gain a clearer understanding of the size of the universe. The event will also offer a rare chance to explore dark matter and its potential influence on the structure of the universe. Dark matter, the mysterious substance that makes up about 85% of the universe's mass, does not emit or absorb light, making it difficult to detect. However, observing how light and matter behave around Betelgeuse after its explosion could provide indirect insights into the role dark matter plays in the universe's large-scale structure. Betelgeuse's supernova will also bring us closer to understanding the life cycles of stars, particularly how massive stars contribute to the creation of elements essential for life. Supernovae are the key cosmic events responsible for spreading heavy elements throughout the universe, elements that eventually form new stars, planets, and even living organisms. By studying Betelgeuse, scientists will gain valuable insights into how these elements are created and distributed. The cultural significance of Betelgeuse's explosion is also noteworthy. For millennia, humans have looked to the stars for guidance, inspiration, and meaning. The disappearance of one of the most prominent stars in the Orion constellation will spark philosophical reflections on the transient nature of the universe. In some cultures, such cosmic events have been interpreted as omens or signs of great change. Betelgeuse's explosion may inspire a mixture of awe, wonder, and contemplation as humanity witnesses one of the universe's most extraordinary phenomena. As Betelgeuse's supernova unfolds, it will likely become one of the most documented astronomical events in history. The sheer scale of the explosion, combined with its visibility to the naked eye, will capture the imagination of billions. Scientists, educators, and media organizations will have the opportunity to engage the public on a global scale, offering explanations about the science behind supernovae and their importance to the cosmos. The aftermath of the explosion will be equally important to study. The remnants of Betelgeuse will form a nebula, a cloud of gas and dust expelled into space. This nebula will eventually contribute to the formation of new stars and planets, perpetuating the cycle of cosmic evolution. Observatories will monitor this nebula closely to understand how material from a supernova interacts with the interstellar medium. Betelgeuse's explosion will also shed light on the timing and predictability of supernovae. While scientists have made significant strides in understanding these events, many questions remain unanswered. For example, what specific changes occur in a star's core in the moments leading up to its collapse? How does the surrounding material influence the explosion's brightness and behavior? Betelgeuse's proximity offers a rare chance to answer these questions with unprecedented detail. For the general public, the event will likely become a cultural moment, sparking discussions about humanity's place in the universe. Artistic expressions, literature, and even philosophical debates may draw inspiration from this cosmic spectacle. In many ways, Betelgeuse's supernova will remind us of the vastness of the cosmos and the interconnectedness of life on Earth with the processes that occur on a galactic scale. In conclusion, Betelgeuse's anticipated supernova represents a unique convergence of science, education, and human curiosity. It is a rare event that bridges the gap between the scientific community and the public, providing an opportunity to marvel at the beauty and power of the universe. As we await this monumental event, we are reminded of the fleeting nature of stars and the profound impact they have on shaping the cosmos, and ultimately life itself. Individuals from varying backgrounds observed the passing of a star. This terrific occasion is likely to reignite interest in space exploration and stargazing, bringing more people into the quest for knowledge about the universe. Novice astronomers are already preparing for the event, as modern technology allows almost anyone with a camera or telescope to observe and record the cosmic explosion. This democratization of science will unite people across the globe, all watching and documenting the same fantastic phenomenon from their unique vantage points. Betelgeuse's explosion is not only a grand celestial event but also a stepping stone for future exploration. The data gathered from the cosmic blast will illuminate how we study other stars, particularly as we venture further into space with missions to other planets and stars. Understanding the life cycles of stars and the properties of supernovae is essential as humanity seeks to expand its presence in the solar system and beyond. Additionally, the explosion will reignite interest in the search for extraterrestrial life. Supernovae are fundamental for spreading the building blocks of life, such as carbon and oxygen, across the universe. By studying Betelgeuse's explosion, scientists can better understand how life's essential elements might spread to other planetary systems, potentially sparking life elsewhere in the universe. As Betelgeuse's impending explosion approaches, it is set to become one of the most significant astronomical events in recent memory. Its cosmic explosion will provide an abundance of scientific data, enhancing our understanding of the universe and captivating people around the world. Betelgeuse's death will mark the end of a massive star but also symbolize the ongoing cycle of creation and destruction that governs the cosmos, reminding us that from death, new stars, planets, and even life itself can emerge. As we prepare for this historic event, the world will eagerly watch the night sky, anticipating the moment when one of the universe's most powerful forces bursts into view. For both scientists and stargazers alike, Betelgeuse's final journey will be momentous. As Betelgeuse nears the final stage of its life, one of the more speculative but fascinating possibilities linked to its impending explosion is its potential to shed light on some of the universe's greatest mysteries: dark matter and dark energy. These elusive forces are believed to account for most of the universe's mass and energy, yet they remain poorly understood. Some hypothesize that supernovae, like the one expected from Betelgeuse, could hold the key to unlocking some of these mysteries. Supernovae release immense amounts of energy and radiation, and some scientists believe these powerful forces could interact with dark matter in ways we can observe and study. One intriguing theory is that dark matter exists as weakly interacting massive particles, WIMPs. If WIMPs exist, their interaction with the energy released by Betelgeuse's massive explosion could provide clues to their nature. Such a discovery would be groundbreaking, offering the first direct evidence of dark matter, a phenomenon that has puzzled scientists for decades. Additionally, there is hope that Betelgeuse's explosion will provide insights into the nature of dark energy. Dark energy is the mysterious force driving the accelerated expansion of the universe. By studying how light and energy behave during Betelgeuse's cosmic explosion, scientists could gather crucial data on how celestial events like these might interact with the fabric of spacetime itself. Although still speculative, this type of research could revolutionize our understanding of the fundamental forces shaping our universe. If Betelgeuse's cosmic explosion proves to be a pivotal event for unraveling the mystery of dark matter and dark energy, it will secure its place as not only a spectacle for astronomers but also one of the most significant cosmic events in history. The stage is set for Betelgeuse's grand finale, and with it, a once-in-a-lifetime opportunity to unlock some of the universe's most profound secrets. As experts continue to monitor Betelgeuse's life, its inevitable explosion will serve as a turning point for astronomical research. The event is expected to spur a surge in funding and interest in cosmology and space exploration. Institutions worldwide are already preparing missions and research projects to study not only Betelgeuse but also other supernovae, black holes, and massive phenomena. A deeper understanding of supernovae and their implications will have profound ramifications for future space missions and humanity's understanding of the universe. With new tools like the James Webb Space Telescope, JWST, coming online, the ability to observe distant supernovae in unprecedented detail will broaden our knowledge of stellar death. The JWST, with its infrared capabilities, will allow astronomers to observe the earliest stages of cosmic explosions and the material they eject into space. These observations will provide insight into the formation of stars, the growth of galaxies, and the distribution of heavy elements across the universe. This event also holds broader implications for the search for extraterrestrial life. The explosion of massive stars like Betelgeuse offers an opportunity to study the conditions necessary for life's building blocks to spread across galaxies. Supernovae are known to produce the elements essential for life, including carbon, oxygen, and nitrogen. The debris from Betelgeuse's explosion could even contribute to the formation of new planets and stars in the surrounding interstellar space. As these elements spread, they create the conditions for life to form in other corners of the universe, sparking questions about the possibility of life beyond Earth. The explosion will also highlight the vast distances and time it takes for information to reach us. The light and radiation from Betelgeuse's cosmic blast will take 642 years to reach Earth, underscoring the immensity of the universe and how much remains to be discovered. As we witness this event, it will remind us of both the insignificance and significance of human life within the grand scale of the cosmos. This realization may foster a deeper appreciation for space exploration and the need to protect our planet. Culturally, Betelgeuse's impending explosion has the potential to leave a lasting legacy. As the cosmic blast unfolds, it will become a shared experience for humanity, igniting curiosity, wonder, and philosophical reflection. People from all walks of life will gather to witness the event, whether through telescopes, online platforms, or simply by gazing at the night sky. The event will undoubtedly inspire future generations of scientists, artists, and dreamers eager to explore the mysteries of the universe. In the long term, Betelgeuse's cosmic explosion may even influence how humanity approaches space exploration. As we move closer to launching missions to Mars and beyond, the need for advanced space technologies and a deeper understanding of celestial phenomena will be more pressing than ever. Betelgeuse's death will mark not only the end of a giant star but also the beginning of a new chapter in humanity's exploration of the cosmos.